Hello, everyone. It is wonderful to be here at this event and have the opportunity to address you. And for that, I must thank Melvin DeCuna and our Omani host for creating this platform. I'm lucky enough to lead the energy transformation pillar at the U.S. State Department's Bureau of Energy Resources, where we develop and execute international energy policy. Our work seeks to carry out the administration's top energy and climate goals, including advancing decarbonization efforts, promoting energy security, and supporting economic growth through energy development. And we focus on energy diversification to achieve those goals. This encompasses the deployment of renewable energy, energy efficient solutions, alternative fuels, flexible grids, decentralized energy generation, and transparent and efficient energy markets that reflect the true cost of supply. And to do this work, we don't only engage with companies and national governments, but also cities, states, and provinces, because so much of energy transformation is occurring at the subnational level. Of course, to achieve any transformation, there needs to be a strong technology push and a market pull. Consumers signal to governments their priorities. Governments then need to reflect those priorities in regulation and incentivize R&D that leads to heavy investment in technology at a scale that brings down costs and in turn creates demand for the solutions necessary to achieve our goals. So with that in mind, today I would like to talk about cost breakthroughs, supply chains, supporting policies, and finance, the building blocks of the energy transition, and the components that my colleagues and I are focused on in the MENA region and worldwide. I will first start off with the technology piece because that's expected to fuel energy systems. We know that clean tech will be needed to not only meet expected demand growth in the power sector, but also replace retiring power assets and support increasing electrification of sectors currently dominated by fossil fuels, not to mention advancements in hard-to-abate sectors such as heavy-duty transport and industry. Fortunately, many of the technologies necessary to decarbonize the power sector already make economic sense. The cost of wind, solar, and storage have dropped dramatically. According to IRENA, in the last decade, the average LCOE for solar PV modules has fallen by 85%, onshore wind by 56%, offshore wind by 48%. And as a result, what we see now is that renewables are the cheapest source of new bulk electricity in countries that contain 2/3 of the world's population. And further supporting their growth is storage. According to Bloomberg, at an all-in cost of $132 per megawatt hour, a 4-hour utility-scale battery is outcompeting gas peakers in a number of markets. And of course, there's a tension in bringing down costs for long-duration storage. This has a trickle effect. These cost advantages are accelerating the massive and rapid deployment of renewable energy. We're already seeing that the vast majority of capacity additions globally are renewables. And the IEA predicts that global installed wind and solar capacity is on course to surpass natural gas in 2023 and coal in 2024, which essentially means the wind and solar capacity is expected to double in the next 5 years, and that is just in the base case. If we are more ambitious, as we aim to be, it will be higher. And we are going to need to see growth not only in commercial technologies, but emerging ones that can address the transport and industry problem, such as hydrogen. Now, with that said, we need to look beyond additional capacity additions. We have to remember that if we care about climate, then one of the most important things we can do is increase efficiency. So we better utilize the infrastructure that we already have. This includes operating the assets we have strategically, utilizing digital applications, including predictive digital twins for asset management activities. It also includes electrical interconnections to leverage regional variations in demand and supply, and demand response as a tool for reliability. Of course, we can't talk about the widespread deployment of clean tech without discussing the raw materials, such as critical minerals and metals, which those technologies require. The growing demand for those materials and the manner in which they are acquired and processed must be addressed for large-scale transformation of the energy system to succeed, as we need stable and constant supply. To meet our climate goals, resources such as graphite, cobalt, and nickel will need to grow over 20 times. And according to the IEA, lithium, which is key to batteries in transport and power sector applications, need to increase by more than 4,000% in the next 2 decades. To address this, my bureau established the Energy Resource Governance Initiative, or ERGI. It's a multilateral effort to promote sound mining sector governance and resilient supply chains. We use the shared experience of countries with mature mining industries to help build capacity of countries with significant mineral resources to sustainably develop those mining sectors and increase private investment, which then also increases economic opportunity. And this is important because the energy transition needs to be an economic success story. We're also bringing reuse and recycling into the conversation because we need to use less when we can. And though recycling may not be a short-term solution, it is important in the long term. For EVs, mineral extraction and battery manufacturing can account for up to 50% of total life cycle emissions of the vehicle. And according to the US Geological Survey, if all batteries are recycled cobalt could account for almost 1/3 of global cobalt demand by 2045, while recycled lithium could account for over 1/4 global lithium demand. So the supply chain story is an ever-evolving one. Now, to push all our goals, we need policy. Technology, even at ever-decreasing costs, can only go so far if the policy environment is not conducive to bringing that technology to scale. We need to make sure that capital is flowing to these projects because though they are scaling fast, it's not fast enough. Regulation and market design need to account for externalities such as the environment and environmental damage, and as a result compensate technologies for the benefit they provide in terms of those externalities, as well as the benefits to system stability. In the power sector, that often means compensating resources through market products. And of course, policy needs to push alignment of finance with climate goals. Now, this brings me to my last point, or the block. The investment needed to meet climate goals is substantial. According to the IEA, to reach net zero emissions by 2050, annual global clean energy investment will need to more than triple by 2030. And luckily, we have seen a significant level of interest in ESG financing. The Global Sustainable Investment Alliance reported that sustainable investing has grown more than 50% to more than $35 trillion over the last 5 years, which means that about $1 of every $3 managed globally is seeking a profit from ESG projects. And we have seen the green bonds and loans from the global banking sector exceed the value of fossil fuel financing so far this year. But it's still not enough. We need to scale not only commercial technologies to reach our goals, but emerging technologies, which means that in addition to investors, we need companies in every sector and governments to not only purchase renewables to offset their power demand, but build demand for technology that addresses hard-to-abate sectors and support early markets for things like zero carbon steel using hydrogen. With all that said, I should note that we also realize that we need to support countries with their climate goals, which is why the United States committed to double its annual public climate finance contribution to developing countries by 2024. From a baseline of around $2.8 billion a year. And we're working with other donors to commit more so that we can use that money to mobilize trillions in private capital. This is critical because we're setting records right now for billion-dollar disaster events. So I often find it important to point out that if the transition seems expensive, it is often because we haven't considered the alternative. With all that said, I would like to finish by highlighting that there is incredible opportunity in the MENA region, and we're seeing that energy exporting countries in the region can finance projects on a large scale and leverage that capability to become innovators in the transition. And we see large-scale deployments of renewables and some of the lowest cost as well, not to mention plans for hydrogen build-out, including green hydrogen facilities in Oman. In our dialogues with governments in the region, we see this incredible opportunity not just in building these technologies, but sharing resources, including through efforts such as the Gulf Cooperation Council Interconnection Authority. And we're glad to be a part of supporting a piece that contributes to that effort to build regional energy markets to improve grid reliability and increase opportunity for clean tech. We hope to continue this work. The energy transition will take an incredible amount of collaboration. It is truly a team effort. So thank you for your time and thank you for all the work that you are doing.